Hello, welcome to the first video for Math 120. So you'll see I'm lecturing from the notes that are available on Canvas in the files section, these PDF notes, and we'll fill these out as we go on through the video. And so this first video is just review, it's chapter 0. So it's just reviewing some functions, some basic idea of functions and basic ideas about x-intercepts, y-intercepts, and some simple examples of how you find these things. And then we'll start to getting into more material, calculus-like material in the next week or so. Okay, so just remember what a function is. A function is like a rule, right? It assigns to each number x a unique number, which we denote by the function at x or f of x. So the way I think of a function, I always often draw this diagram that we have like a machine, which is like this silly box. And we would input into this machine a number x, call this machine f for a function, and the machine outputs exactly one number, which is this function f or this rule f evaluated at that number x. So it assigns to each input, each number that you input into the rule or the machine, f a unique output, which we denote by f of x, the value of the rule at x. So often we denote in calculus and many applications, we'll denote functions by formulas involving x. So here we have example of two functions, right? The first one, fx is equal to 2x minus x squared plus 5. So the way to think of this is that for each x, in this example, for each x we feed in, the function outputs the quantity 2x minus x squared plus 5. So what we want to do here is we want to figure out the output if we input 3, so f of 3, and if we input 1/3, f of 1/3, and so forth, f of minus 0.1 and so forth. So let's do that. Let's do that together. So we can just compute this. So f of 3, we input 3. So the output is 2 times 3 minus 3 squared plus 5. So that is equal to 6 minus 9 plus 5. And then you just do some math. So this is 11 minus 9. So the output is 2 in that case. So notice what I did, right? So for each place x, where I see an x here in the formula, for each place where I see an x, I input the number 3, right? And then I compute the result given by the formula evaluated at 3. So that's what I was saying with this silly box diagram. For each input x, it's outputting the quantity 2 times x minus x squared plus 5. Our input here was 3. So the output of this was 2 times 3 minus 3 squared plus 5. And if you work it out, it's equal to 2. So let's do another one. So we're all like fractions, right? So if we input 1/3, the output is 2 times 1/3 minus 1/3 squared. And it's good to watch your parentheses here. Remember that you're subtracting 1/3 squared. It's not minus 1/3 squared, it's minus 1/3 squared. Plus 5, and so now we have to do some more calculation. So we have 2/3 minus 1/9 plus 5. And if we want to do this without a calculator, maybe it's good to practice. We should get everything to a common denominator, which is 9 in this case. So this would be 6 over 9 minus 1/9 plus, and we have to do 5 times 9 is 45. So 45 over 9. So you get, if we add all this together, we get 56 plus 45 is 51. And then minus 1 will be 50 over 9. And maybe I will let you, for practice, I'll let you guys do this last one here, minus 0.1. And you can do that by either working with the decimal, or you could do it by converting it to a fraction, whatever whatever pleases you, whatever way it pleases you. So let's do another example. So in this second example, right, our function is f at x is x to the minus 2. So that means that for the input x, the output is x to the minus 2. And you should remember from rules of exponents, a negative exponent is just a positive exponent, but in the denominator. So x to the minus 2 is the same thing as 1 over x squared. And I think realizing that will right away will help you to do this calculation. You might hear some cat noises in the background. They might show up. They might come visit us, but they're busy right now on what they're going to do. But we have to do this calculation. Okay, so let's do this for 3. So, oops, sorry. If we input 3, right, f of 3, the value of the function of 3 is 1 over 3 squared, which is just 1/9. This isn't too bad. Let's input 1/3. F of 1/3 is 1 over 1/3 squared. So that's 1 over 1/9. And now hopefully you remember this basic rule of algebra. When you divide by a fraction, you invert it and multiply. So this is just 9. And similarly, if we wanted to do f of minus 0.1, this is 1 over minus 0.1 squared. And now you're squaring something that's negative, so it'll become positive. But so it's 1 over 0.01, which is actually 100. Okay, so hopefully this isn't too shocking. It's a nice review. And if you have any questions, we can talk about when we meet via Zoom, live meeting. Okay, so another thing we want to review at the beginning of this class are the idea of intercepts. So what are the intercepts of a function y equals f of x? So this is kind of, a lot of what we're going to do this class is going to be connecting some algebra ideas to graphing ideas. And calculus really is about studying how functions change and quantities that are modeled by functions change. So it's really in some ways about connecting graphical ideas to algebra ideas. And this will be the first kind of review of that kind of idea of connecting algebra and graphs. But we'll do much more of this as we go on. Okay, so the x-intercepts are ordered pairs where f of x crosses the x-axis. Okay, so how do we do that? So to find the x-intercepts, we set where when you cross, remember the little axes, right? Y, x. If you have a function and it's crossing the x-axis, the point where it crosses the x-axis, the y-coordinate of the function is 0, right? So to find the x-intercept, we set y equal to 0 and solve for x. Now, this in general can be very hard to do. We'll do several examples where you'll be able to figure out the answer. But for a general function, this is often an impossible problem, but we won't have to worry about that too much. The y-intercepts are a little easier. So the y-intercepts is the ordered pair where f of x crosses the y-axis. Oops, sorry, let me clean that up a bit. And to find the y-intercepts, we set x equal to 0 and compute y is f at 0. So that's very straightforward. And there's actually, because it's a function, there'll actually only ever be a single y-intercept. So another kind of picture here we have, where does it hit the y-axis, right? So that's y and this x. That's exactly where the x-coordinate is 0. So the point where it hits the y-axis is where the x is 0. So we just need to compute f of 0, what the output of the function is at 0. Okay. So now we have some examples of finding the intercepts. So the y-intercepts tend to be easier. So let me, but first let's take this guy here and let's put it in a form that more like a function form. So we can solve for y, just to rearrange the formula a bit. So we have 2y equals 12 minus 4x. So y equals 12 minus 4x divided by 2. So that's 6 minus 2x. So it's now in function form. So I'll just write it over here. So the y-intercept, I'll just write, I won't write the whole word intercept, I'll just write inter. The y-intercept is just given by set x equal to 0 and solve. So y of 0 is 6. So the y-intercept here is 0, 6. I'm running out of some room, so I'll borrow some room from here. Now for the x-intercept, right? So now for the x guy, okay, now we have to set y equals 0 and solve for x. So if we do that, we get 0 is 6 minus 2x. And if we solve this equation, we get 2x equals 6 or x equals 3. So the x-intercept is 3, 0. So that's kind of a very simple example. We'll talk about this a little bit more next week, and that this is an equation of a line. So for lines, find the intercepts, very easy game. We're going to have a very efficient way of reading them off from the equation soon enough. What about y equals 7? Well, this one's actually just easy peasy. We can even just think about what the graph of this looks like if we wanted to. Y equals 7 is a vertical line at height 7. So the y-intercept is 0, 7, and there are no x-intercepts. So that's an example of this horizontal line at height 7. If you plug in, the output is always 7 no matter what you plug in, but you can just see it from the graph. Horizontal line, height 7, y-intercept 7, no x-intercepts. Okay, so these are great, these are nice examples. We were able to find things very easily, but these are lines we want to be able, the calculus and algebra of lines isn't that interesting. So we want to be able to work with a little bit more interesting functions, and the next level of difficulty are quadratic functions. And for quadratic functions, we need to remember some things from factoring. So one thing that will be very, very useful for us is the difference of squares factoring formula. So maybe I can even write this in a special color if you like. So a squared minus b squared. So if we factor that, we get a minus b times a plus b. And you can verify this formula by just expanding or foiling, if you like, out the right-hand side here. And you see that the middle terms will cancel, just giving you a squared minus b squared. So you'll have an ab term and a minus ab term, they'll cancel. And the end you'll just get a squared minus b squared. So this is a very, very important formula. I hate to say memorize things in math, but you should kind of have it at your fingertips. It's something that is so useful and comes up so often that you want to know, that you want to have it available right away. So what's the more general thing for factoring a quadratic equation? So if you have a general quadratic equation, ax squared plus bx plus c, and you want to factor this, you want to find the zeros, the solutions of this equation, that's given by the quadratic formula. So that's x equals minus b plus or minus b squared minus 4ac over 2a, right? And so this is something, that comes up so much often in math and in applications that it's a really, really good idea to have this kind of memorized at your fingertips. You've probably used it up the wazoo, I don't know how many times. Okay, so let's do some examples with this. And I'll show you how these formulae kind of work in action to give you intercepts. So again, the idea of connecting, like the idea of an intercept, graphical idea where a graph's hitting either the x or y axis, to an algebraic idea in factoring formulas. So that'll be one of the themes kind of what we look at this semester. Okay, so find the intercepts for this quadratic function. 4 minus x squared. So again, let me start with the y-intercept first. So that's just plugging in 0. So 4 minus 0 squared, of course 0 squared is 0, is equal to 4. So that's not too interesting. So the y-intercept is 0, 4. Okay, the x-intercept, we're going to have to use some of our tools. Okay, so for this we set f of y equals f at x equal to 0 and solve for x. So we get 0 is 4 minus x squared. And then if you like, and there's different ways of kind of skinning the cat here, but we talked about this difference of squares, so we can make use of that here. Where the now the a is going to, or the a squared is going to be 4, and the b squared is x squared. So a is 2, and the b is x. So we can use that to get a nice formula, a nice factorization. So we get that 0 is equal to, then using the difference of squares, 2 minus x, 2 plus x. So 0 equals this factor, 2 minus x, times this factor, 2 plus x. That means that 2 minus x is 0, right? Or 2 plus x is 0. So now we've reduced the problem to figuring out the solution of two linear equations, or basically the problem to finding out the intercepts of these lines. And we just did that a minute ago. And this is an easy problem. So this one here gives us that x is equal to 2. And this one here is x is equal to minus 2. So a lot of mathematics, and when you get more and more complicated, into more complicated mathematics, is about reducing complicated problems to problems you know how to solve using certain tools. So here we had a quadratic, we want to find the y-intercept. We did our tool was this difference of squares factoring. And then that led us to basically the two equations, which involve figuring out y-intercepts or solutions to linear equations. Sorry, x-intercepts. So there are two x-intercepts in this case. Oops. So we have 2, 0 and minus 2, 0. So that's a nice example of factoring, difference of squares. So let's do another one that's a little bit more involved, where in this one here, where our function is 3x squared minus 12x minus 36, the difference of squares does not apply directly. So we'll have to be a little bit more clever about what we do. So again, so let's do the y-intercept. So we get f of 0, plug in f of 0, and 3 times 0 squared minus 12 times 0 minus 36. And this is just going to be, guess what, minus 36. So the y-intercept is just 0 minus 36. Very easy. And now for the x-intercept. Okay, so set fx equal to 0 and solve for x. Okay, so we get 0 equals 3x squared minus 12x minus 36. Now, you could say, okay, I can solve this using, where did it go? The quadratic formula here. But this can be, and especially this quantity, this quantity in the square root can be kind of cumbersome to calculate. So I only use the quadratic formula where I absolutely have to, where I can't factor it by sight. And I think this one, we can actually get away with factoring by sight. So let's see what happens here. So if we can divide by 3, we get 0 is x squared minus 4x minus 12, right? And we should be able to factor this by hand. So I'm going to say here. So this is equal to x minus 6, x plus 2. If we factor that out by hand, and you wouldn't have been wrong to use quadratic formula, but this is I think a much faster way to handle the problem. So again, we have two solutions. So this implies that x is equal to 6 where x is equal to -2. So I'm just skipping this step of setting the linear factors equal to 0, like I did above. It's going directly to the answers. So we reduce it to 2 linear factors being 0, which we know how to do. And so 2 x-intercepts again. And they are 6, 0, and -12, 0. So we're in good shape there. Okay, so you just take a minute to look at that. And so again, if you can factor by site, I think that's much better than, having to use the quadratic formula when you don't need to. It's a more involved, cumbersome calculation. It takes more time. You might have to pull out your calculator and stuff and to enter things correctly into the calculator, which I can almost never do, and it's a pain. Okay, so now there's 2 more examples I want to talk about today. Again, quadratic. And so now these are going to be cases where it's not going to be we're not really going to be able to factor it by sites. So let's do the y-intercept first. It's always quite easy. So f of 0, and if you plug in 0, okay, we don't have to write everything out anymore. Maybe we're getting good at this. If you plug in 0, anything involving x is going to go to 0. So you're just going to be left over with 1. So the y-intercept is just 0, 1. Now the x-intercepts are going to be a little trickier. So we set this equal to 0. And we try to solve. And now you look at this, well, I can't divide by 2 because 3 isn't divisible by 2. 1 clearly isn't divisible by 2. So the trick that we used to kind of simplify it last time isn't going to work. It's not obvious how this factors. I don't see an obvious factorization. So I think we need to use the quadratic formula. Well, or you can try, you can try to factor it by hand, but it does have not so awful roots, but maybe we should try the quadratic formula. So x is equal to minus b is 3, plus or minus b squared is 9, minus 4 times a is 2, right? Times c, which is 1, so we don't have to worry about that, divided by 4. So this is 3 plus or minus. So 9 minus 8, well, that's just 1. So that actually works out to be pretty easy over 4. So we get the 2 solutions are 4 over 4. And with the subtraction, we get 3 minus 1 is 2 over 4. So the roots are 1 and 1/2. So those are the intercepts. So the x-intercepts in this case (1, 0) and 1/2, 0. And when you look at this and you realize that the formula works out so nicely, you kind of say, oh, I could have factored this by hand. It actually factors as, 2x minus 1, x minus 1. So that's actually the factorization, but unless you're doing factoring all the time, you might not have seen that by sight. But just when you see the quadratic formula spit out something so easily, it did factor quite easily. Okay, so the next and the last one, though, we have no choice. This one, you really do have to use the quadratic formula. The roots here are actually irrational numbers, and you won't be able to factor it by sight. So the y-intercept, again, we just plug in 0. Everything involving an x will go to 0. So f of 0 was minus 1. So the y-intercept is 0 minus 1. And now for the x-intercept, we can again use the quadratic formula. So we want to solve. the equation 0 is 5x squared plus 2x minus 1. So we use quadratic formula. So remember in the formula here, this is the A, this is the B, and the C. So x is equal to minus b is minus 2 plus or minus b squared, so it's 4 minus 4 times 5. But now the c is minus 1, so that actually does matter to have the negative sign there, all over 2a, which is 10. And so now, sorry about this, we end up with minus 2 plus or minus the root of 24. Right, so you have 4 minus 4 times 5 is minus 20 times minus 1 is plus 20. So it's 4 plus 20 is 24. Divided by 10. And now we should simplify this a bit, and this square root is going too long. Right, so going to this next line, so the x is equal to minus 2. So 24, right, is 4 times 6. So you can move, so remember this is 4 times 6. So you can move the 4 out of the square root and it becomes a 2, and you get, right, you take this 4 out of the square root of 4 is 2, so you get minus 2 plus or minus 2 root 6 divided by 10. And now we can do some canceling. So minus 1 plus or minus root 6 divided by 5. And so these are the two x-intercepts. So they're irrational. Root 6 is an irrational number. That radical does not simplify. So the 2, I'm running out of room. But the two intercepts are, it doesn't matter which order you put them, minus 1 minus root 6 over 5, 0, and, sorry, and minus 1 plus root 6 over 5, 0. Okay, so I hope that wasn't too dull. I hope you kind of remember some of these things, and it was a bit of a refresher. And we will continue now to study some graphs, lines in more detail, and then start to build up the foundations of calculus pretty quickly. So if this stuff is unfamiliar, or it's like I can't, you don't remember this at all, I'll be happy to go over it in more detail in our live meeting. Thank you for paying attention.